All right, guys. So this whole idea of derivatives with respect to this will be for worksheet 18. So this is worksheet 18. It's just a way to kind of look at things a little differently. So if we're looking at this, so what we're really saying, we always say the derivative of y with respect to x, and that's how we get dy over dx. So what we're really saying is what happens at y when we change x just a little bit. That's that whole as h approaches 0 idea. So what we're really saying is that we've got the derivative of y based on some function of x. So if we look at it, what we're saying is this. If f of x is 3x squared, here's my relationship f of x. So this is my derivative. This is what's going to change a little bit. Then I need to find the change in y that happens when I change this a little bit. So if we kind of look at it from a power rule kind of point of view, and this may not be mathematically correct, but it helps me kind of process what's going on. There's a 1 right here. So if I do the power rule this side, that 1's going to pop out there, and then this is going to disappear. But the issue with that is there's still dy dx, because that's the relationship. What's happening to y if we change this a little bit? That's where the dy dx comes from. And then what's the change? Well, with respect to f of x, or with respect to x, that change is going to be 6x. So that's where we get dy of dx. So this is the change in y with respect to x. So it could be anything though. So if we can take this out of here, so we know that we've taken the derivative of y. We really have taken the derivative of y, and we've taken the derivative of f of x. So then, to drive home the concept, there are different types of problems, and let's tackle this first one they get you. So they say, well, if y equals the square root of x squared plus 1, then take the derivative of y squared with respect to x squared. You're like, what? Okay, so with respect to, to x squared. So let's first tackle y squared. So y squared is going to be equal to x squared plus 1 squared. Okay? So now I'm going to get this idea right here of y squared is equal to x squared plus 1. So right now I've got y squared, and I want it with respect to x squared. So let's look at this. So the derivative of y squared with respect to the derivative of x squared. So that really tells me, since we took the derivative of the left and the derivative, on the other problem, the problem we did prior to this, we took the derivative of y, this side, and we took the derivative of x. We can really rewrite it as this. Y squared is equal to the derivative of x squared plus 1 over the derivative of x squared. So what is the derivative of this? It's 2x. What's the derivative of this? It's 2x. So the derivative of y squared with respect to x squared is going to be 1. So basically what we're doing on these is we're taking the information given and we're taking the derivative of the top and the derivative of the bottom, which technically is what you do with something like this, like I showed you. I took the derivative of y, and I took the derivative of f of x. That's what I did earlier, because if f of x was 3x squared, the derivative is is 6x, so that would be 6x over the derivative of y, dy dx. Well, if we move that over, that's where we get our dy dx equals 6x. Okay? So, as we deal with these things, it's just another way to look at with respect to. That's just a quick little example for you guys to help you out with the worksheet 18. It can get a little confusing, so just kind of follow with that derivative. So let's look at it differently now. All right, this kind of gets a little confusing. Okay, so basically on 13 through excuse me, 16. 13 through 16. You're going to take the derivative of the top over the derivative of the bottom. It's basically what that it's saying. So you've got to take the information they give you about dy, they got to take the information they give you about dx, and that's how you're going to solve 13 through 16. Okay? Other than that, hang in there, guys. We're getting closer and closer to about a third of the way through the derivative unit.